Well, since we are at the top of the hour and we have a few people that have joined us today, I would like to use the time for those people that are new to go ahead and introduce themselves and where they're from, and maybe just stick your contact in the chat so other people can say hi and welcome connecting with you. So do we have any introductions?
I think I'm fairly new. Joe Andrakia with Stephen Winter Associates. I think I was on one call a while back, but haven't been able to attend for a while. We do consulting on a lot of energy efficient projects, including Passive House, and we do some NREL research and work with NYSERDA and things on monitoring and program write-ups and things like that.
I love it, Joe. Thanks for introducing yourself. Now I know another person at Stephen Winters.
Hi, I'll go. This is Susan Picorni. I'm with JEA in Jacksonville, Florida, and I'm new to this group, so look forward to learning.
Great. And Susan, sorry, you did say Susan, right?
Yes.
Yes. Okay. Susan, what do you do at JEA?
I do water conservation and energy efficiency for the residential side of our business.
Awesome.
And my counterpart, who has her hand up there, she wants to go next, does our commercial. I'll let her introduce herself. Go ahead, Gigi.
I'm Gigi Carroll, also with JEA, and I'm responsible for our commercial energy and water conservation program. And I've thrown my email and contact information in the chat.
That's awesome. We have a res team meeting too. Like, I don't want you to leave our meeting, Susan, but I want to make sure maybe Susan Harris can make sure that you get the res team meeting invite too.
Yes, I do think I have that. And the reason I joined today is that Gigi is new to the group. So I'm still working with her. And I figure there's something I learned, even though it's just a commercial working group, I think the two can cross over sometimes.
Absolutely. Noe, do you want to introduce yourself?
Yeah, thanks, Kashmira. This is Noe Contreras. I'm with the Northwest Energy Efficiency Alliance. I'm a senior product manager working on dual fuel commercial heat pumps.
Thanks, Noe. Anyone else like to introduce themselves?
I'm on the camera. For those who don't know me, I'm Jarvis with Flow Environmental Systems. We'll be chatting a little bit later today on our stuff.
I'm looking forward to the presentation. All right, well, as people are still joining, again, feel free to put your contact info in the chat. And if it's not apparent that we don't know what you do, throw that in there too so people know why to reach out to you. And we can get going. So if you want to just roll it and I'll read the compliance statement, the antitrust compliance statement. The AWHI is a member-supportive collaborative of professionals from across the United States. Our diverse membership includes numerous competitors, and care must be taken to scrupulously abide by federal and state antitrust laws. Members should remember that antitrust compliance is important at all times at this and other AWHI meetings. Participants should not discuss competitive pricing, profitability, market allocations, customers, or promotion of a particular product or accessory. So when we share these products in these meetings, they're really just an opportunity to inform everyone else about the products that are in the marketplace. So with that, I'm gonna, next slide, I think Susan's gonna give us an update on Heat Pump Water Heater Day.
I am. Hi, everyone. I'm Susan Harris from New Buildings Institute, and I'm here to talk to you a little bit about the third annual Heat Pump Water Heater Day, which has evolved to become an entire day dedicated to heat pump water heater education and awareness. There has been an evolution of Heat Pump Water Heater Day. It began just 3 years ago. It was a dream of Joe Wachunas, who has led the effort to make it a reality. The first theme was a play on the phrase tree hugger. We encouraged people to hug their heat pump water heater and share that online. We hosted one online event and produced short videos with Joe as Heat Pump Water Heater Man and created social media messages for sharing. And then in year 2, with expertise from Jess Bergman and January Fall, working on polished images and the theme Everyday Energy Superheroes, we had 4 online events and new resource drops through the day. And our most recent theme was Market Transformers. Each year, we've added new creative and programming elements. For this year's growth, we brought on social enterprises for support, and sponsors were enlisted. We played off the concept of transformers and their adaptability to create professional, innovative, playful calls to action and drive participation. The imagery incorporates elements from heat pump water heaters, you may notice that, and the Energy Star label into the transformer characters to align the theme with the technology. We created a series of graphics that we could leverage for promotions leading up to, on, and following Heat Pump Water Heater Day. We created a dedicated promotional webpage for organizations and individuals to help promote the event and their participation. A social media press kit provided individuals with pre-written content they could edit and graphics for sharing easily on their social media channels. A partner toolkit provided customizable playing cards to highlight their team members or projects and share them with their networks. These tools help create a visual social media takeover, build momentum, and amplify our reach. Presenters also had access to the branded materials, and these branded materials helped create an immersive and cohesive brand experience for attendees from across the United States and the world who tuned in throughout the day. We also created a new awards program. Here at AWHI, we know there's a lot of great work happening. And so this new Excellence in Water Heating Awards program gave us an opportunity to recognize that excellence by individuals and groups who are leading the way to significant advancements and installations of heat pump water heaters or increasing equitable access to heat pump water heaters in homes and businesses. A judges panel with AWHI working group leads and industry thought leaders made the difficult decisions to choose our winners. We had leading speakers from across the industry. Highlights include a keynote recording with Secretary Granholm, opening plenary with Commissioner Andrew McAllister. There was representation from every manufacturer, and a wide range of represented technologies from 120 volt plugins to central heat pump water heaters and new manufacturers. There was also a fun heat pump water heater dance party video with Joe traveling around the country, meeting with manufacturers, and just having fun with it. There was also a heat pump water heater giveaway. Here are our results. We had 876 unique registrants from 49 states and 12 countries. There was 6,600 visits to the AWHI website during the month of October. This rate of visitation to our website has increased over the years. You can see the prior year just below that was 4,000. And we had 150 organizations posting online about Heat Pump Water Heater Day. And we see here Secretary Granholm and her posts, along with her video. There was 5,869 impressions on LinkedIn. And we asked people to include on their posts a hashtag, which you see here under Secretary Granholm, hashtag HPWH Day. And if you visit LinkedIn and type in that, you'll see all the different posts that happened throughout the day and leading up to the day. And with that said, We have another great event coming up soon next week. I hope that you can join us for a sustainable commercial refrigeration webinar, which will include Sean Jarvis from Flow Systems, who will be speaking with us a little bit later in this meeting. I'll put my email in the chat if you have any questions for me about Heat Pump Water Heater Day or other related items. I'll also be sending out an email soon with the resources related to Heat Pump Water Heater Day, so you'll know about their availability. And with that, I'll hand the microphone back to you, Kashmira.
Okay, next slide, please. So I have the pleasure to share out the commercial heat pump water heater roadmap. A small group of us that lead the AWHI Commercial Heat Pump Water Heater Initiative meet annually to kind of say, okay, what did we do? And what do we need to do next? So we're all aware from our 3 pillars, which I call product development demonstration tools. That's traditionally where most of the engineering comfortable people play when we do new technology. Then there's the kind of market awareness piece of it. We basically want everyone and everything to know about the technology and the tools and want it and want to install it. And then the third thing is we talk about, okay, what carrots and sticks do we have? What standards, specifications, codes, program design models are there? And what's happening in that area? So go ahead, next slide. So what we're hoping to really accomplish in 2025 includes a few different things. So I'm going to start with the one in the middle, which says provide support for early adopters with Dash app monitoring for fault detection and diagnostics and maintenance and training. And the reason I want to say that, because I want to give a huge round of applause to, it seems to me what I'm seeing is that a lot of the public housing organizations are taking leading steps in installing central systems. And so there's an app called Dash App that provides real-time monitoring for these systems, which aids in identifying the maintenance things that might need to happen, system changes that might need to change, something not going right, and really help with the commissioning and ongoing maintenance of that. And so that's something that we're looking to try to provide financial support for, uh, getting additional information to those early adopters. And I think also we'll be rounding out, like, how can we make this Dash app monitoring more available to everyone? It's such a great tool with these new systems. The top one, and we're also going to talk about some of the benefit projects later today, is that we want to see more qualified product list demonstrations throughout the country with more products and more applications and M&V. And so for those of you who don't know, the qualified products list is maintained on the NIA website. There's a few NIA people on the call, so maybe somebody can drop the link in the chat. The importance of the qualified products list is it's going to give you an entire system design. So like a residential water heat pump water heater is one thing in a box. Well, a central heat pump water heater is kind of the same way when you look at the design. It's a whole bunch of things that go into that box, and this is how to put them together to be able to get performance and predictable savings. And so we've got 8 products, I think, on the qualified products list right now, and we're hoping to expand that. But more importantly, we need to see other regions use the products on those lists and in the specifications in the qualified products list, and have MMV on those so we can continue to show that there is performance of these systems. Or if there's not, what do we need to do to change them? The third thing has to do with tools. So there's an EcoSizer tool. I think there's a link also on NIA's website, possibly a link on Ecotope website. It's an open source tool that supports the sizing, hence sizer, in the design of originally for central heat pump water heater systems with a swing tank configuration. And so what we'd like to do is we'd like to add more configurations and more applications. Originally, that tool is just meant for multifamily, and so there might be other applications, commercial applications, residential applications, not individual residential, but the kind of facilities applications that this can be used for. And then we also want to have an option where, well, what if you have gas backup? So what would that look like? And the reason for that, for those people that might be going, no, not gas, is it really just diversifies your system and provides additional reliability and hopefully actually gets more penetration of electric heat pump water heaters. So we'll see hopefully more uptake of that and a little bit of resource diversity with a gas backup. There's additional work that needs to happen on load shifting, both how to correctly design a system to have optimal load shifting results and what kind of controls are needed and other capabilities to help the utility sector really take advantage of these giant water tanks, water batteries going into multifamily and other applications. And then finally is where AWHI is kicking off a 2-year unitary non-residential small commercial application study. I know that we have A.O. Smith, Ream, maybe IntelliHot, and that I can't remember. I'm going from my memory. Maybe Sandon is in there also. So looking at small commercial applications and presenting results maybe in like the next 2 years. So that study's just kicking off. Next slide. Okay, so for market awareness, what we want to do is we want to expand the awareness of the advanced water heater spec. So I was thinking about quirky little things because Joe always has the good ideas. Well, go tell a friend about the QPL. Go look it up and go send it to a friend. The link's in the chat. You can do it while we're working here. And then we want to promote best practices from a market awareness perspective. We want to be able to really get out to those supply chain actors, including distributors, architects, designers, utilities. I'm speaking for our own service territory, which covers roughly 140 utilities in 4 Western states. A lot of people still need a lot of help getting these systems in there. So that's where the QPL will really help when you look at it as a domestic hot water system. We want to develop product-specific training, targeting maintenance contractors. We want to publish the market research and the market characterization, the training needs and program development. That's happening, I think, as part of our scaling up in Magic Grants. And then also explore the collection of aggregated, anonymized sales data. Why? Not because we want to drag people through the mud and have you give us our secret sauce or anything like that, but we really want to see what markets are taking off in and what markets are they not taking off in, and maybe need some help analyzing the barriers and removing them. Next slide. Just a time check for myself. Okay, and then for specifications, codes, programs, Adam Gage, who's on the call, you find his name in the list, is and Jeff Wicks, for those of you who don't know, is retiring. So Adam's stepping into this area. So please do reach out to him if you have some questions. We want to engage more with manufacturers and distributors and get more fully specified, fully packaged systems on the qualified products list. So by way of recall, so to remind everyone, there's 3 types of products. There's the traditional, you go to the store, you get your parts and pieces, and you put your system together. Then there's one at the opposite end, which is like, you know what, do this full package system, fully packaged skid mount system. We'll drop it into the location, bring it in on a flatbed truck, and it's ready to go. And then in the middle is the concept of a specified system. Think of like an IKEA desk that comes in that you pick up at the store in a flat box. Okay, well, everything's going to come in a box with the directions on how this needs to go together to build your system. We want to remove barriers to natural refrigerants. So Susan, you mentioned that you're having a refrigerant session later coming up. So might stick that in the text also, so chat, so people know where to hit. I want to sign up. We're going to have refrigerant changes happening in January of this year, so we really need to determine where we're kind of headed next. And so we want to remove barriers to natural refrigerants such as R290. We need to get alignment with some big players in the field, and that includes the CEE and Energy Star, and ensuring that the specifications for performance align so we can get that consistency amongst the different organizations, and that will support utility programs and manufacturer sales. So really want to work on that with our Manufacturers Action Council. Our goal is to develop a energy savings measure for the Northwest. It's the Northwest Regional Technical Forum, RTF. And then also, have some initial discussions and conversations about incentive programs. Should they be upstream programs, downstream programs, midstream programs? What is the best way to really move the market? Also a great topic for the Commercial Manufacturers Action Council and programs. Am I done? Next slide. Okay, I think I have this one. So we're looking for utility programs that are rebating. Thank you. I actually asked for the slide to come in. I forgot. So if you are aware of an incentive utility program, could you please stick that in the chat, even if you just know a couple words of it, and we'll do the follow-up. We're just trying to get a survey of what is out there, if anything, and kind of pull that together for a future presentation. So thank you for sharing that information. Next slide. Next slide. There you go. So I would like to introduce, oh my God, I just forgot your name. Is it Ryan? Sorry, we're Sean. Thank you. Thank you, Sean.
Yes.
I was looking for you. Thank you. My apologies. So I'm really excited that Sean's going to present this new amazing product. We've had the opportunity to work with them through AWHI and help see that product's really going to perform well. So Sean, please go ahead.
Excellent. Thank you. That was great. Let's see. Hey, I can advance the slides. Perfect. So, hey everyone, I'm Sean Jarvis. I'm with Flow Environmental System. I'm the Chief Technology Officer over here, and just basically means I get to do a lot of fun stuff and make heat pumps. So for those who don't know who Flow is yet, we are a U.S. company. We're here and specifically here to bring environmentally responsible HVAC tech to the market. Getting around decarbonizing, detoxifying, figuring out how to stop burning stuff to make heat, and really serve those harder to electrify end use cases, whether that's high temperature heating delivery, that's low ambience, that's simultaneous heating and cooling, and a whole bunch of other stuff like hitting the codes and regulations that we're all working so hard to put in place. And so we all know the problems. I don't have to tell this group, but the idea is it's going quickly, and we're building New York City basically every month right now globally. So the voluntary action is really wonderful, but the regulatory action is really kicking in now. So we're talking heat pumps and refrigerants, really. And we know the push towards natural and why that is, but it's always nice to see it in a chart format. Really, we have four main categories of what we're going against with the new regulations. That's global warming potential, ODP, safety class, and PFAS. You can see clearly if you look across the spectrum, the naturals stand out, and it's an engineering problem with what we do. The transcritical system.
Sean?
Yeah.
Are you showing us something?
I am not. Why don't you advance the slides then on your end? So jump ahead. Perfect. Okay, go one more.
Okay.
There we go. I'm going to watch you because apparently mine advances without showing everybody else. All right. So with that, you see everything I just said. Global warming potential, ODP, safety class, and PFAS. Naturals are phenomenal in every one of those categories, whether it's R290, ammonia, or CO2. The trouble is the safety class and making sure we have a good engineered solution. So with that, we are specifically focused on CO2 products, and those are a transcritical system. And so we have a specific way to deal with that. And Please advance to the next slide. So every system you saw in there with refrigerants, whether it's your propanes, 410As, 454Bs, 134As, you name it, they're all in the subcritical category on the left side there. So that's basically a pressure enthalpy chart. You don't really care about it all that much. Just know there's a red dot. Subcritical is below the red dot. CO2 heat pump is different because the critical point's about 88 degrees. So if you can go above that point, you can do some really cool and amazing magic stuff like high discharge temperatures, 100% sensible heat extraction, and decoupling the temperatures and pressures. So we can now optimize to be a really good heating solution or a really good cooling solution or anything in between. Next, please. So this is our Answer CO2 heat pump. It is an air to water or water to water based system designed specifically for HVAC heating and cooling duty, as well as domestic hot water production. It can do simultaneous heating and cooling without a reversing valve, meaning it could do all of that at the same time or just a single mode. And for the first time out there, it can do really high return water temperatures that usually haven't existed in CO2 systems. And so we can now start tackling 180 degree supply with high returns anywhere from 140 to 160. We have a couple different form factors with what we do, whether it's splits or packaged, and then we can do either water-to-water geothermal heat recovery on its own or a gas cooler and split it by up to 1,000 feet. And you can talk like Kashmira was saying and just package it all together and have a system that drops on and in place quickly in a commercial form factor. Next. So with that, we have a number of sizes and configurations that go a little bit further. There's systems that you go and put into buildings, fit through a normal commercial door. And then it can also be modularized for larger and larger systems with a variety of different options for the gas coolers because every building's unique snowflake. So whether it's a tight form factor feed bank, horizontal for low sight lines or high snow loads, or vertical for with plenum fans for high pressure ducted type applications, there are solutions for all of them. Next, please. So these things can do a lot, as I mentioned. They can do cooling, heating, simultaneous, and true simultaneous, no reversing valve, unlike modular systems, one's in cooling, one's in heating. Huge operational range, anywhere from -40 up to 120 degree ambience. It works exceptionally well with no defrost derate. Because of this funky transcritical system, we can use the residual energy to basically have an always on defrost with that we can improve. And we can do everything in accordance with the AWHI 550, 590, and we're working on the advanced heat pump water heater specs and qualified product lists, qualifications, all that good stuff. Next, please. So I kind of wanted to leave you with this. We got our traditional systems, you're burning things, furnaces, boilers, chillers. We're all making heat pumps, but a lot of the heat pumps are limited in what they can do from high temperature hot water or cold climates or defrost and so on. A system like this can now eliminate all that extra stuff. We can get rid of the redundant defrost modules, get rid of those redundant electric boilers or water-to-water boosters, and use all of the energy in the same device out of the same box. So you get 3x capacity with the same power feed. So now all your equipment is smaller, more compact, and we can do a lot. And also, when we do that, we can even save energy on our main powers of our building. So there's a lot we can do there. Next. And last one I just want to leave you with is we're building an ecosystem device where we can talk to the chilled water, the hot water, the domestic water, any kind of refrigeration loads that go into it, interface that with heat recovery, storage, geothermal, even the air side interface. We're doing some really amazing work with national labs, Department of Energy, and California Energy Commission to even have the grid interoperability be part of it in a system ecosystem like this. So at the end of the day, you got an environmentally responsible heat pump that is essentially future-proof with all the good benefits that you see here on the screen. And I think that's about it on time check for today. So thank you. Appreciate the opportunity. And if there's any questions, I do see ConX specifications. I assume that's explosion-proof stuff. Is that correct?
Negative. The outline of this appears to be like you're shipping sea containers, the Connex boxes. Is this
yeah.
Connex form factor, or is this just happen to look that way?
It fits in a shipping container, yes. Standard 40-foot cube containers can handle this, no problem. It's designed around a global platform for distribution across different marketplaces. And then the small one also fits in there and stacks nicely. Everything's designed around freight elevators, commercial doors, and shipping containers, and loading docks, and standard commercial trucking with no oversized loads. Great question, though.
Sean, thank you so much for this very informative presentation. And if anybody would like to see all the slides, don't worry, we're going to be following up this meeting with all the slides, so you'll get to see those slides that we quickly moved through here today.
Thank you.
And then I see next we have another presentation. Kashmira, are you here with us?
Yes,
Great.
I'm here. Sorry, my headset just croaked. Can you hear me okay?
Yes.
Okay, great. So I don't know, did Vijay make it to the meeting?
Yeah,
Vijay,
I'm
are you
on.
here?
I'm here.
Oh, wonderful, wonderful. Well, you don't know that I actually saw your presentation at an AWHI meeting, and given that we also deployed a skid system up in Seattle a little bit before this one, I didn't know that the Daikin Mega Q had come out as a skid. So I'm so excited for you to share that with everybody here.
Sure thing. Sure thing. So my name is Vijay Thomas. I work for the New York Power Authority. Those who know, we are one of the largest government utilities, providing 25% of power to New York State. I'm talking today about a project that we did with the New York City Housing Authority at a development called 830 Amsterdam. It's a single 20-story high-rise. I can take control of the slides. I can move it around. Okay. Everyone see the next slide? 830 Amsterdam. So, yeah. So, the 830 Amsterdam. What it is it's a 20-story high-rise in Manhattan on Amsterdam Avenue, and NYPA came to us saying that they wanted to do something innovative, and so they wanted something innovative that, because they have to replace the boiler and hot water systems. They were out of date and ready to be changed out, and they wanted a solution that would bring them into the future. And so this was back in 2019 that they came to us with this request. And so we then utilized design build project delivery in order to basically find the most innovative solution. And the idea there, is we wanted to retrofit a public housing building to accept electrification measures. We wanted something with heat pumps for both hot water and heating and cooling, and we couldn't displace the residents, and that was kind of the thing. One thing to note: project is substantially complete. It's done. We're just wrapping up a few small minor things, but it is working and things are going well. So to get into the project a little bit more, I want to just recognize our partners. So when we went out for design build delivery model, we were able to team up with Dynamic US and Venture Engineering, which some of the guys from Dynamic US, Roger and Doug, I see are on, and Ventrip, Ed Twiss. Feel free to jump in anytime I say something that's not right. So they were the team that basically created the design, as well as constructed the end product. Now, some of the challenges that we had are challenges that are going to happen throughout any Northeast installation in a retrofit installation. So, few of the challenges I just want to highlight is the residents would be present during the construction, because economically impossible to move them in a way that would make sense. So the thing is, whatever we did, whatever we installed, had to be installed in such a way that the services were maintained and outages were limited. So that's a key major issue when thinking about how to develop these products and move them forward. The technology at the time when we were in this proposal went out or in 2019, 2020, we saw that there was a lot of hot water heating systems, but they were all for single residential, not for multifamily. And so there was a concern about that, but we were like, we need to find this. So that was another issue at the time, which I'll explain how we got through that. Resilience is extremely important because working with NYCHA, we want to make sure, in any case, you want to make sure people have hot water. Space was limited for additional equipment because we would have to figure out, again, that first point, which was limiting outages and maintaining service. There would have to be a very tight room for new equipment. And then on the other side of it, everyone's concerned, especially back then, was cold climate, freeze protection is a big issue. It's cold climate heat pump was a concern. Freeze protection is always a concern. But now on the other side of it, we also had a very aggressive project schedule, and cost was fixed. So as I mentioned, we used the design build delivery model. This allowed us to basically find a manufacturing partner to work with that was on the process of getting things right. Daikin was that equipment partner. They were in the process of getting UL listing, and so we basically walked with them through that process and were able to then get to a point where they were ready to deliver. And so design build process, I can't speak more like enough praises to how it's helping bring innovative and newer technologies to market. So here's a typical layout of the Daikin system. So the couple pieces that are key is that you have the heat pump, you have a cascade system, and then you have a tank. And then and this is the model that was what we were working with. And then going from here, we go to customizing the system for our project. So one of the key concerns, as I mentioned, was that we don't have much space. It's a 20-story high-rise. There wasn't many open other spaces to utilize, and so we had to basically potentially use a external tank. We had to put the tank outside because the boiler systems were still running. The hot water systems existing were still there in the tank in the boiler room. So space was limited. So we also didn't want to have a failure point with heat tracing, and so the solution that the engineer of record, Venture Engineering, as well as working with Daikin and Dynamic US came up with was to utilize a glycol tank on the exterior, and that provide some additional resiliency. So because it acts almost like a power battery in that way. So getting into that a little bit in kind of photos here, we were on a tight schedule, and being on an aggressive schedule, Daikin was able to build a skid mount solution where basically it was factory factory put together, and that was with the condensers and cascades units being placed on this on the system, and then transported and dropped in place. So everything was piped and put together in their factory in Houston, and then delivered over to New York City for installation. That made our aggressive schedule possible. And then here's an image of the glycol tank that's on the outside, all heat traced and insulated. and here are some pictures of the indoor installation. So once we were able to clear up some of the space, we were able to get the glycol system comes in. There was enough space in interior to have the additional heat exchangers, as you guys can see, as well as we had some the idea of resiliency, some additional indoor hot water heaters, hot water tanks rather, and that's basically that, and that is my presentation. So if anyone, Ed or Doug or Roger, have anything else to add, please feel free.
Thanks, Vijay. Just giving your team members a chance to respond if they're interested. Can we open it up? Does anybody have any questions? Oh, go ahead.
Yes, hello. This is Roger Dow from Dynamic US. Sorry, my camera doesn't seem to be working, and it took me a second to get clicked on there. Anyway, I want to thank you, everyone, for allowing us to participate in this presentation, but mostly thank you, NYPA, for entrusting this, the very first electrification project in New York City housing, involving, and this project brought, as Vijay mentioned, air conditioning to the residents of the 830 Amsterdam that had never been in place before. And it's the very first electrification project, as I mentioned, within NYCHA. And Vijay is absolutely right. It was the design build process that enabled us to do three things. Number one, create a design that could be constructed in a manner that would have least amount of disruption to all the tenants. Number two, we selected partners, manufacturing partners for this particular project, and engaged them early in the design build process to ensure that the products that we were specifying within this program and could be implemented and constructed appropriately and installed in a manner not to disrupt operations to that housing unit. And third, from a schedule perspective, we delivered a schedule. We were able to execute and deliver the schedule from design through construction in a very short period of time, minimizing the environmental impacts to the residents. So that could have been done in a typical design bid build type of procurement methodology, and it was the design build methodology that enabled us to mitigate risk and enable our partners to partner with us and collaborate with us in solutions. And the net result was a fantastic project that was delivered to the residents. And we have a bunch of very happy residents there. So it's a great program. And as you know, New York City Housing Authority, with the largest public housing authority in the country, arguably the world. It's been argued many times, but this project kind of set the tone for other projects to happen within the city and other electrification enabling projects to occur within the city. So it's been a great project to be a part of, and we thank you very much for allowing us to participate.
And one thing I just wanted to add to that, and was that like last month or the month before, I forget exactly when, but I attended the resident association meeting for this building, and there was like 25, 30 people in that from the residents in the meeting, and I just mentioned how I asked them how the new hot water system is working for them. I got applause and a standing ovation, because they said this is the first time they had consistent hot water that hasn't been an issue for them. And honestly, this new technology and what this group is doing to bring innovative technology to residents is helping people. So I mean, we should all have a realization that we're doing good work that's helping people.
Yeah, that's fantastic. And the thing that I mentioned earlier is here out west, we also have public housing agencies really taking the lead in building these amazing central heat pump water heater systems and improving the quality of life for so many people. So thank you for coming and sharing. And I don't know if John or someone else from NIA can stick in the chat. We did a similar project with Mitsubishi, in their Heat 2.0 system at Seattle Housing Authority right about the same time, a little bit before. So we can put that in there, and you guys can peruse that too. Are there other questions for Vijay or the engineering team that put this project together? I can scroll the chat and see if there's anything else.
Yeah.
Oh yeah, there is a question about, and I was wondering this too, the MMV. And somebody said that is a project to monitor the system. Is this part of the DOE benefit FOA?
There is a DOE has a EPRI is working on a program called Connected Communities. So this building falls under that. I don't know if anyone from EPRI is there to say more about it, but they are working on connecting, getting all the data, and then analyzing it. So we haven't.
Sarah, maybe Sarah knows. Sorry, Sarah, your name came up here at the top. Letter B, if you're listening. Maybe not. Yeah, I'm not seeing anyone else. And do a quick scan. Okay. So we're ahead of schedule, John. So take your time in answering questions and talk about this amazing tool that we've name dropped so many times, the qualified products list. And Vijay, thank you for joining us. I'm looking forward to doing more work in New York and seeing those benefits.
Yeah, very impressed. Very impressive project there. Great to see that kind of work happening in New York. So I'm John Heller, and I'm going to follow up some of the stuff that Kashmira talked about early in this meeting and make a plug for expanded use of the qualified products list from NEA's advanced water heating spec and why it is a tool that will really help us drive faster market transformation of heat pump water heaters. And let's see if I can figure out how to advance the slides. So this is just a reminder that when we talk about the qualified products list, the products that are listed are actually systems. It's the full heat pump water heater system, including the storage tanks, the controls, and everything needed to deliver hot water out of the mechanical room to the building. And that is because you could have the best heat pump in the world, but if it's not designed and installed and controlled properly, it's not going to function well. So the first point is to remember that we're talking about full systems when we talk about the qualified products list. And we're trying to address with this the primary market barriers for transforming the market to commercial heat pump water heaters. High first cost, design complexity, perceived risk, and just general lack of experience and awareness out in the world on how to put these systems together and deliver them. So we feel that that standardization through the qualified products list will address all of these barriers and make this much more easy to expand at scale. So the parts and pieces of the advanced water heating specification include the specification itself, which can be found on NEA's website, and somebody from NEA can drop it into the chat. But what the spec does is really defines the minimum design and performance criteria for a complete system. And this is so that there's some standardization of how these systems go together to reduce the risk and uncertainty for designers, owners, utilities, and so forth. We know what we're talking about when we say a complete heat pump water heater system. Then we have the product assessment data sheet, which is the mechanism that manufacturers can use to submit their products for inclusion on the qualified products list. It demonstrates that that they've thought through the entire system design and are delivering a product that meets all the basic requirements of the advanced water heating spec. There's, in addition to just documenting how the whole system goes together and is controlled, other requirements on the advanced water heating spec are things around warranties, things around alarming requirements, optional ways to do measurement and verification, and to do load shifting controls and so forth. Then when the manufacturers submit through the PADS system, it will the process will run a modeling tool that we call the EcoSim on that product in a specific design configuration in a range of climate zones to predict the performance of that system out in the field. And then it's listed on the qualified products list with a predicted average annual energy performance for products that meet all the requirements of the spec. And the efficiency that's listed, or the predicted average annual efficiency that's listed, is more than just the efficiency of the heat pump, which is what we call the equipment COP. And that right now, the DOE rating is a single point efficiency rating, which really has very little meaning when we're talking about, when we're trying to figure out how much energy is this system going to use out in the field. We can also talk about the primary plant COP, which is if you combine the storage and the heat pump. This might be, for example, an integrated tank where you've got the storage and the heat pump. But what this does not necessarily include is the energy associated with the temperature maintenance system, which might have its own efficiency rating, whether it be provided by electric resistance or another heat pump or even gas. And so what we're really interested in and listing on the qualified products list is the energy efficiency of the entire system rolled together. So all the energy that goes into run the heat pumps and any backup heat, and all of the heat that is produced to heat the water up that's coming in from the city, plus the heat that's needed to maintain that water hot through losses in the distribution system. And so if you look at the qualified products list on NEA's website, you'll see something like this. And again, where we list the company, it's not necessarily just the manufacturer of the heat pump. So you'll see there that in one case, we've got Rheem, who manufactures the heat pump. And on the bottom line there, we've got Small Planet Supply, which is a packager of heat pumps. They don't make a heat pump, but they package up the Sanco 2 heat pump into a full system. And then we're also showing the design configuration. So the same heat pump might be listed on the qualified products list in a range of different design configurations because the way that it's configured impacts its performance. So you can see there that we're showing a Rheem with configured as a multi-pass return to primary storage. And the Small Planet Supply product is shown there using a series swing tank configuration. And then we list the predicted average annual system COP in 4 different climate zones, hot, mild, cold, and very cold, with a tier rating depending on the level of efficiency that's predicted. The other thing that we're showing on the qualified products list is this recognition of the different market delivery methods that Kashmira mentioned a little earlier from at one end of the scale, we've got a custom engineered solution where the designer is speccing the different components and they might come from multiple manufacturers, to a specified built-up system where all the parts and pieces come from a single distributor and are delivered as a package with design support and field support to make sure that it goes together the way that it's intended to a complete, fully prepackaged system that's assembled in a factory and dropped into place. And these are kind of in order of decreasing complexity for the installers and designers, decreasing risk, and decreased need for direct experience using heat pump water heaters. And that's then also shown on the qualified products list, where you can see here that similar manufactured product, a Colmac heat pump, one of which is delivered as a custom engineered solution, another as a fully specified built-up system. So this gives some indication to the to a utility program about how much field verification might be needed for these different delivery methods. So for example, if you've got a fully prepackaged system or a fully specified system where the provider is providing field review to verify that it was installed per their specs, that might need relatively little field validation for a utility program to make sure that they're getting the savings that they're paying for. Whereas for a custom engineered solution, the utility may decide that they need to have measurement verification installed, documented functional testing, startup by a certified provider, submittal review and field review documented from the engineer of record, and so forth, to make sure that that it's all coming together in the field. Because there are a lot of details that need to be done right for to deliver the performance that's expected out of these systems. And this kind of highlights the central role of these system packagers and in my opinion, they're kind of critical to enabling this technology to go to scale rapidly. It's going to be very difficult to educate all of the mechanical engineers and installers in all of the different ways that these heat pump systems need to be treated to deliver optimal performance. Whereas if we've got a smaller cadre of system providers, sales engineers that really understand their products and are able to deliver the training to the engineers and support the engineers and the installers. If we put a focus on that smaller number of people, they will go out and help ensure that the rollout of this technology is smooth. And again, there's much fewer of those people that we have to that may need to be incentivized and supported than if we're trying to educate the entire country about commercially pumped water heaters. So a summary of the main points I was trying to get across with this short presentation is that we need to focus on the full system. The system is the widget, not the heat pump itself. That the system suppliers are the key to making this a less painful transition. And so focus on those fully specified systems and fully prepackaged systems rather than custom engineered solutions might be the best way to focus utility programs. And we can use this qualified products list as the basis for savings estimates for utility programs going forward. It's ready to go. Questions?
I love it, John. Everyone's ready to go out and install one of these.
And the other thing I would mention is that what we'd like to see is more of those fully specified product offerings from different suppliers around the country be listed on the qualified products list, so that people in Chicago can look at the qualified products list and say, oh, this trusted product rep has a package that they've put together as a fully designed package of products that if I do it the way that they tell me to, I know what to expect in terms of performance. Right now we've got a lot. There's a little less than 200 listing line items on the qualified products list. A lot of those are custom design solutions. There's several that are fully specified systems, but mostly from West Coast suppliers. Not a lot from the East Coast, Southeast, Midwest yet. So we'd like to see those listings expanded. And then we'd like to see utility programs begin to be developed, pointing to the qualified products list as a mechanism.
That's right. And one of the things Kevin put in the chat is that, are we getting East Coast suppliers on the QPL? And I guess my answer is not yet, but can you help us, Kevin? I mean,
Yeah.
we have the NEEP list, right? And we use it up here on the West Coast for HVAC, for heat pumps. And so I think the better outcome for manufacturers is to see their products on this qualified products list. It de-risk problems for them too, on the proper installation, making sure that things are installed and designed and specified correctly. So yes. And John, did you mention the ones that you hope to be getting on the list here soon? So the manufacturers that are on the list and the manufacturers that you're working to get on the list in process.
Well, there's several new products coming out that we'll be demonstrating through a DOE benefit project called MAGIC, Made in America Grid Integrated Commercial Heat Pump Water Heaters. So that will add some products to the list, but also existing products that have supply chain in different parts of the country that are ready to sell a fully integrated product. We'd like to see those coming onto the list. And I think it's that the supply chain doesn't know about the qualified products list yet, and the utilities are not yet pointing to it as a mechanism for program. So as that begins to happen, this'll speed up.
Great. And if anybody wants to partner with us on this, just drop a line in the chat. Thanks, John. Thanks for sharing. Susan, we run the next slide. Oh, it looks like I was able to do it. Okay. So we have a little bit of time. If we want to end the meeting early, that's fine with me. But I want to make sure we still sharing slides. I'm only seeing.
Something happened to the slides. I'll get back to sharing them. Just take one second.
That's fine. Yeah, so let's just open the floor. Is there any questions or any things that people would like to see in an upcoming meeting? Don't be shy. This is your time to, chime in. Okay, then. We've got it all figured out. Love it. Well, then let's wrap up the meeting early. Oh, you have your hand raised.
Yeah, I was just going to point out that at AHR last year, great place to have it in the winter in Chicago. There was lots of interest in this whole notion, and I think there will be more manufacturers from the Midwest and the East because of their interest. So I wouldn't shy away from it. I would say if developers, architects, engineers, low-income housing can point to the qualified products list, you'll see more people get on. Most manufacturers, when they hear about a qualified products list like that, and they understand it, which is very self-explanatory, they get on it. So don't shy away from pointing to it.
Great, thanks, Jeff. Anything else? Okay, well, with that, let's call it a wrap. It was a success. And I'm glad everyone could join us today. It looks like our next meeting is for August. Again, if folks have an interest of something they'd like to see in a presentation, just go ahead and drop it in the chat or send an email to the email above, and we'll work on that.
Obviously, this is an old slide. So our next meeting will be December 12th. We'll see you in December.
Joe, you caught that. You get the prize. It was like a highlights magazine. You had to figure out what was wrong with the slide.
Yep.
Okay, thanks everyone.
Thanks, everybody.
Bye.
Bye.